Medium ISP, the AT ACEdle by AT ACEdle. This project aims to create a functioning wordle game that can be played physically. It does not rely on a computer to function, employing an LCD screen and 5 momentary push buttons. This project mainly focuses on the software aspects of this course more than the hardware. One of the fundamental concepts within this project is voltage division regarding the buttons. Voltage division through each specific button replicates that of an LCD keypad shield. An LCD keypad shield is an extension of the LCD screen, which is a board placed on and soldered on top of an LCD. The buttons implemented within this circuit mimic how the LCD shield works by placing every button to control the cursor in series with one another and connecting analog pin 0 to it for the circuit to read the voltage successfully. When wiring these buttons together, since each button is placed in series, junction point A0 will read 5 volts when no button is pressed. What happens is that depending on the specific button pressed, a certain voltage will be displayed. When the first button is pressed, the path of voltage will go straight from the junction point of A0 to the ground, resulting in a voltage of 0 at that specific point. However, when the second button is pressed, the voltage has to travel through a 330 ohm resistor to get to ground, altering the voltage to 0.6 volts at that specific location. Furthermore, the buttons are connected to pin 2, an external interrupt pin. An external interrupt pin on a microcontroller is a hardware input that triggers a specific action or routine when a particular event occurs, such as a change in voltage or signal. It allows a microcontroller to respond immediately to external stimuli without continuously checking for changes, enhancing efficiency in embedded systems. Pin 3 is also an external interrupt pin for the Nano, which the select button is hooked up to. Another key component of this project is the LCD screen. The liquid crystal display, or LCD screen for short, is a 16 by 2 row screen that can display up to 32 characters, commonly alphanumeric information. This code for this project is long, however, it is pretty simple. The code begins by declaring all of the necessary functions, such as the debounce interval. In the section where everything is declared, the code sets the predefined words that are wanted within the circuit. This is set by creating a car array that can be called later in the code. The circuit can randomly pick a word by getting the microcontroller to read the voltage on a specific pin and retrieve a word based on the voltage read. However, when the pin is left floating, the voltage can range as it is not set, making the microcontroller randomly select the word. Furthermore, the code then declares the alphabet by calling an array, which writes every letter in ASCII. ASCII letters are characters represented in the ASCII encoding scheme, allowing computers to understand and display alphabetical characters and symbols. This means that each specific number correlates to our particular letter. The code later then declares specific functions such as the placement check, which will cross-reference and check each letter, and depending on whether the letter is in the correct spot, the specific LED will turn on. As stated previously, the buttons are wired to an external interrupt pin, meaning that when a change in voltage is encountered, the command will run. The ISR_button command is a command that, depending on which button is pressed, increase or decrease a specific variable which the cursor is set to. So moving right would increase X cursor position, and then the cursor would be set to that variable, moving the cursor 1 to the right. Words can be inputted by moving the cursor and pressing the select button once the cursor is over an underscore. The word can also be checked by pressing the checkmark button. Once the correct word has been guessed, the corresponding winner or loser screen will be displayed whether the word was guessed in 6 tries or not. This project incorporates a few other details to help the player, such as including a guess counter in the top left corner and attaching op amps to each LED to make them brighter. A PCB was also created for this project. Thank you for taking the time to listen to my project, the AT ACEdle.